Let's start with 4.3, solving polynomial inequalities. We're going to now be combining 4.1 and 4.2. In 4.1, we looked at how to solve polynomial equations. In 4.2, we looked at how to solve inequalities. Now, we're going to be looking at how do you solve a polynomial inequality. Once again, the difference between equations and inequalities are in equations you find specific answers, finite answers. In majority, it's a lot of questions, you have one or two or three answers. Now, because we have inequalities, you have an infinite amount of answers. There's a range of answers that are possible, and you need to be able to find all of them, or to at least come up with an equation that represents your solution set. Starting with this one. X cubed minus 2x squared plus 5x plus 20 is greater than or equal to 2x squared plus 14x minus 6. Just like with solving equations, we need to get it in factored form, and we need it to be equal to 0. Obviously, we don't have an equal sign, so we're going to say factored form, and you want everything on one side and equal on the other side. Or sorry, 0 on the other side. So let's bring everything over here. We're going to bring this over and subtract 2x squared, subtract 14x, and add 6. Because we're going to do the opposite of all of these. Start with x cubed. Negative 2x squared minus 2x squared is minus 4x squared. 5x minus 14x is going to be negative 9x, and then 20 plus 6 will be 26, and that's greater than or equal to 0 because we are not multiplying or dividing by any specific, we're not multiplying or dividing by a negative value. What it comes down to now, factor. When you take this and factor. Again, so far there has been nothing different between solving the polynomial equation and solving polynomial inequality. So what we need to do is, I made a mistake, this should have been 16. Right, so that's a plus 16, so this would be 36. Sorry, made a mistake there. So now, in order to factor, we're going to take the factors of 36, 1, positive negative 2, positive negative 3, 4, and so on and so forth. Now, I've already done the work for this, so I know that 3 is a factor. So we're going to go ahead and simplify this down to include x minus 3, and then the rest of it we are going to solve for using synthetic division. So let's go with synthetic division here. 3, 1, negative 4, negative 9, and 36. Bring the 1 down. 1, addition, 3 times 1 is 3. Negative 4 plus 3 is negative 1. Negative 1 times 3 is negative 3. Negative 9 plus negative 3 is negative 12. Negative 12 times 3 is negative 36. 36 minus 36 is 0. Because this was a cubic function to start, this will be a quadratic function. So it's x squared minus x minus 12. That would be x squared minus x minus 12. Obviously, we're going to continue to factor this now. Two numbers that multiply to be negative 12 and add up to be negative 1. So a product of negative 12 and a sum of negative 1. Well, that would be negative 4 and positive 3. So x minus 3, x plus 3, and x minus 4 are greater than or equal to 0. One more step, same thing. We're going to isolate for each of these, and we're going to find that x is 3, x is negative 3, and x is 4. This is now where we have to understand inequalities a little bit differently than we would understand equations. The fact that I put all of these as equal to 4, equal to negative 3, and equal to positive 3 does not answer this question. This question is asking which x values will give me a number that's greater than or equal to 0. I have only found the numbers that will be equal to 0. Well, in any graph, so 3, negative 3, and 4, so this is negative 3, positive 3, positive 4. The only way for it, let me draw a quick function for this graph. The only way for this graph to go above the x-axis or below the x-axis is if it goes through the roots. there's no way for this function to end up down here because it doesn't pass through the x-intercept that way. And once it's positive, it will not become negative. So if I'm looking for when is it greater than or equal to 0, that's another way of saying, well, when is it positive? It can only be positive or negative between the x-intercepts. If this to the right of -3, if it's positive, well, it has to stay positive until the next x-intercept. If it's negative down here, it has to stay negative until the next intercept. So what we do in this case is we solve for our roots, and then we determine what are the y values in between. Are they positive or are they negative? I'm not concerned with how high they go, if it goes up like this or if it goes down like that. It doesn't affect what we're looking for. All we want to know is it positive or negative? Because the inequality wants to find out when is it greater than or equal to 0. So now let's take a look at that. I'm going to erase all of this and leave only our initial simplified equation. To do this, we're going to be using the number line method. Once again, our roots were 3, -3, and 4. The simplest way to do this, you need to have factored form, my mistake. So x minus 3, x plus 3, and x minus 4 greater than or equal to 0. I know the textbook uses a table. I don't like to use a table. I find this method to be a lot easier. I'm going to put down only the roots. So 3, -3, and 4. So I have my roots. I have 1 interval, 2 intervals, 3 intervals, 4 intervals. There's only 4 intervals. There's only 4 different places that could be positive or negative. It cannot cross through at any other point. What we're going to do is we're going to take a number in each interval. So a number to the left of -3, less than -3, I will choose a giant number, so -1 billion. -1 billion minus 3 is still negative. I'm not concerned with the number, I just need to know the sign. -1 billion plus 3, still negative. -1 billion minus 4, still negative. So if I plugged in x is -1 billion, any number to the left of -3, I would end up with negative times negative times negative. Negative times negative is positive. Multiplied by negative, still be negative. Which means for this equation, to the left of -3, my numbers will be negative. Let's take a number between -3 and +3. Well, the easiest number that pops into my head is 0. So if I take 0 and I plug it in, if x is 0, this will be negative. If x is 0, 0 plus 3 is, that's positive. If x is 0, 0 minus 4 is negative. Well, now if I multiply, negative times positive is negative. That negative multiplied by that negative is positive. So this tells me that all the numbers between -3 and +3 are going to be positive. Finally, or not finally, so next step, between 3 and 4, I'll use a number like 3.5. So if I choose 3.5, 3.5 minus 3, well, that's positive because 3.5 is bigger than 3. 3.5 plus 3, that's also positive. 3.5 minus 4 would give me negative. So positive times positive is positive. Multiplied by the negative will give me a negative value. For all x values between 3 and 4, the y values will be negative. And finally, to the right of +4, I choose any number I want that's greater than 4. I'm going to use an easy one like +1 billion. The reason I use that because I don't have to add or subtract. If I have +1 billion, who cares if I subtract 3 or add 3 or subtract 4? From a billion, those are meaningless, negligible numbers. Negligible. So billion minus 3 is positive. +1 billion plus 3 is positive. +1 billion minus 4 is positive. So if I have 3 positives, my answer here will be positive. Let me get this out of the way. What's my question asking for? When will this equation be greater than or equal to 0? It will be positive here and here. My final step is to write that down. That the solution set will be from -3 till 3 and from 4 till infinity. I'm going to make one adjustment here. Because this has greater than or equal to, I know that the x-intercepts are also part of the solution. So instead of using circle brackets, I have to use square brackets wherever there are x-intercepts involved. The infinity still has a circle bracket because it can never actually equal infinity. So solving polynomial inequalities, your first few steps are exactly the same as solving polynomial equations. You want to put everything onto one side, 0 on the other side. Factor your equation fully. Now is where things get different. You have to take each of your roots and just put them on the number line and plug in values from in between each of these intervals into your factored form equation to see if your answer would be a positive number or a negative number. We're not concerned about the actual number. We only care about the sign. Is it positive or negative? And then you finally summarize your answer at the end.